In 2015 there is no MCQ, there is a part 2 question. Check it. Under physics, 9th question, Roman number 3. Check it. Is 2015 Roman number 3, sorry, question number 9, Roman number 3. A VT graph relevant to motion of the above ambulance from the base hospital to general hospital is given below. So here we have an ambulance. It is traveling from base hospital to this ambulance, base hospital to general hospital. Okay, they have given a graph. Check it out. VT graph. My handwriting is very ugly. Don't consider it. Try to understand what I am explaining. Velocity is 60. Here put this meter per second minus 1 units also. It's good. It's good in the sense you should put. You should mark the axis. Sorry. Here they have given time as 40 and this is 20. It is 20, this is 60. Yeah. What's the first question? What is the uniform velocity with which the ambulance has traveled? Uniform velocity means constant velocity. Here in this motion, which part has a constant velocity? This part has a constant velocity. Okay, what's the question they have asked? Uniform velocity. What is the uniform velocity the ambulance has traveled? Simple question. That is 60 meters per second. Roman number 2. Sorry, it's A part, it's B part. If the displacement of the ambulance with uniform velocity is 15 kilometers, that is 15,000 meters. I know I said you in the voice note, for conversion of units from kilometers to meters should be multiplied by 1000. Find the time that is traveled with uniform velocity. Time that is traveled with uniform velocity. You know what's the area under the graph? Area under VT graph, that is displacement, right? That is displacement. So they have given what's the displacement? Displacement is 15,000 meters. Always if they are given in kilometers or in minutes or in hours, if the time is given in hours or minutes, convert those into seconds. If the distance is traveled in kilometers, millimeters or something, convert those into meters and try to solve in the SI unit form. So area under the VT graph is displacement. So what is this area? This is a rectangle. Therefore area of rectangle is length into breadth. So what is the length here? You should find out. Let's take this as T1. That is what they have asked in the question. T1. What is the breadth? That is 60. And what is the area? 15 into 1000. 15,000, 15 into 1000. So T1 is equal to 15 into 1000 divide by 60, cut this. In 15 and 6 you can divide by 3. In 6 how many 3s? 2. In 15 how many 3s? It's 2. Sorry, how many 3s, right? It's 5. So in 100 how many 2s? 50. 5 into 5, 25. 250 seconds. So T1 is equal to 250 seconds. That's the answer. Find the distance between the two hospitals. What is the distance between the two hospitals? The whole area under the graph, right? So ambulance has started here, gone with an acceleration. It has gone with a constant acceleration. Gradient is constant, moved with a constant acceleration, and then it has moved with a uniform velocity. Then the velocity is decreasing, so there is a constant deceleration. It's constant deceleration because the gradient is constant. So I have found out this one, right? So if I find out both these areas, I can add with these 250. I can add those two areas with 15,000 meters. So I will get the distance traveled. Let me do it. So what's the area under the graph? Sorry, what's this area? That is a triangle, right? So area of triangle is half into base into perpendicular height. Half into base is 40, perpendicular height is 60. We can divide by 2. 2 into 6 is 12. So 1200 meters. 2 into 6, 12. At both the zeros. That's okay. Let's take this as A. So area, the distance traveled as D1. So D1 is equal to 1002 meters. So we'll find out this D2. We'll take this area as D2. Half into, here we have the equation, half into 20 into, what's the perpendicular height? That is 60. It's 10. So 600 meters. So what is the distance from their base hospital to general hospital? 1500. That is this 15,000, sorry, 15,000 plus 1200 plus 600. So if you add it, what's the answer?